record. Okay, so chapter 1 was about vectors, just an introduction to you on what vector is, how to add them, how to multiply with the vectors, because we will use vectors throughout the semester, throughout next semester even. So this chapter is about motions. So we have a lot of different motions. For this chapter, we are dealing with linear and also two-dimensional motion. So this is translational linear motion. We have uniformly accelerated linear motion, free fall, projectile, and also the graphical representation of these motions, either in displacement, velocity, or in acceleration. So we will see that later. Okay. So after completing this chapter, these are the learning outcomes. You have to know what is displacement, velocity, and acceleration, how to calculate them, what is the equation, and then use linear kinematic equations for uniform acceleration. Kita akan go through this later. I think this is new to you, linear kinematic equation. And then solve for free fall problems. This is my favorite because basically it's free fall, and solve projectile motion problems. Okay, so this is what this chapter is about. All right, so let's skip this one. Skip Newton. Kinematics. Okay, so what exactly is kinematic? Kinematic is actually describing a motion or the description of a motion. For example, let's see. For example, let's see nama-nama yang dalam ni. Okay. Okay. So let's say Rafiq lah kan, Rafiq. So Rafiq is standing here, and then Ikri is behind him, but Rafiq doesn't know, right? This is Rafiq. Who was this again? Forgot. Oh my god, I have short-term memory loss. I said Rafiq and was it Ikri?
Ikri.
Okay, Ikri, sorry. Teruknya. Okay. So this is Ikri and this is Rafiq. So Ikri dekat sini and then tiba-tiba kan kita punya view. This is the classmates punya view. They see Ikri suddenly going into a projectile. Tiba-tiba je dia melonjak and naik atas, jatuh bawah. Lepas tu, so orang kinematics orang kinematik dia tengok, oh, so Ikri is going up and then stops momentarily at the top and then falls down. So here ada gradient positif, sini ada gradient negatif. So orang kinematik dia nak tengok ni je, dia nak tengok what this motion is about, how to dissect the motion, what happens over here, what is the slope here, what is the velocity here. So this is kinematic. They are not concerned about what happened to Ikri sampai Ikri melonjak ni. Rupa-rupanya Rafiq tolak. Kesian Ikri. So Rafiq jangan buat macam tu So Rafiq tolak Ikri and this is why Ikri kuat gila Rafiq kan. So dia tolak Ikri and Rafiq, Ikri dia melonjak. Okay. But orang kinematik dia tak kisah pun apa jadi kat Ikri. Dia nak tahu motion Ikri ni apa. Oh, menariknya projectile motion Ikri ni. So this is what kinematics is about, describing the motion. We don't really care about the force that is happening. We only care about the motion and we want to know what is going on in the motion. Okay, so this is kinematics. And then we have different types of motion. Kita ada translational. Translational ada linear motion. This is in one dimensional. Boleh jadi, sorry saya pakai nama Ikri lagi. So Ikri is moving up the y-axis. This is still one dimensional even though it's weird and tak macam scary kan. But this is considered one dimensional linear motion. Okay, so yang biasa kita tengok is over here lah. Contohnya siapa lagi nama? Iqbal tengah jalan lalala. So this is one dimensional motion. And then we have the projectile that we saw Ikri flying tadi kan. Terus nampak dia macam ni. This is two dimensional. Why is it two dimensional? Because when we dissect this, it has an X and Y component. Okay, if I dissect over here, ada X and Y component. So this is two dimensional except for this part. This part only has X component. So when you can have components in the X and the Y, it is considered two-dimensional motion. Iqbal tadi dia jalan Bila kita nak dissect vector ni, tak boleh. It's only in the x. So this is one dimensional. Bila kita nak dissect this vector, it's only in the y. So this is one dimensional. Okay, and also we have circular motion. Circular motion is actually 2D. Okay, kalau tak percaya, saya tunjuk jap. So circular motion is actually 2-dimensional. Walaupun macam bizarre, but it's actually 2-dimensional. So this is, let's say we are swinging a pendulum, right? We are swinging a pendulum in a circular motion. Tak tahulah pendulum tu kat mana. Doesn't look right. Let's just eliminate this. So this pendulum is moving in a circular path, and I say that it is moving in 2 dimension because the vector of displacement or the vector velocity has 2 components. Ada x, ada y. Kat sini pun ada ada y, ada x. Okay, so as long as you can dissect the vector into its components, into 2 components lah, it's 2-dimensional. This also applies for a circular path. Okay, and we will go over that later lah. Kita akan go into more detail. So another type of motion is repeated motion. So tadi translational, ada linear, curvilinear, circular motion, and then now we have repeated motion. So repeated motion can be in the form of rotation such as your kipas, right? Kipas rotates dekat paksi dia. So it only rotates, it does not move to the right, does not move to the left. It's only there, but it rotates. So thank God it does not move to the right or left, kalau tak hilang kepala. So this is called rotation motion. And then we have rolling, for example, your ball. Okay, your ball, abaikan ball yang comel ni. So your ball rotates and also moves forward. Bila golekkan bola tu, dia rotate and also moves forward. So that is called rolling. Dia ada 2 types of motion in there, rotation and also translational. Translational dia move in 1D kan, kat sini. Kat sini dia 2D, kat sini dia 1D. So 2 types of motion, and this is called, the combination of both of this is called rolling. Then we have simple harmonic motion, which is a spring. Okay, when I have a spring that is tergantung and I tarik, what do I say? I stretch the spring. What happened? And then I let it go. The spring goes up and down, up and down, up and down. They repeated, so up, down, up, down, up, down. So this is in the ideal world. It does not ever stop. But this is not the case in real world. So what happens in the real world is that the up and down becomes becomes less and less. So it becomes smaller and then smaller and then smaller sampai it comes to a complete stop. So this is called damped harmonic motion, which happens in our world. In the ideal world, it is simple harmonic motion. The up and down does not lose energy. So dia takkan berhentilah sampai bila-bila unless there's a force that tells the simple harmonic motion to stop. So this is ideal case lah. Okay, ideal case. And physics likes ideal cases so much because it makes calculations easy. And this is the real case. Okay, so and then we have wave motion, as the name says, macam ombak air. What else? I can't think of anything else. So macam ombak lah, wave motion, and it looks like a sine or a cosine. Asalkan ada that peak and then going down and peak, panggil apa lah, throw, adalah term-term dia. Okay, so for this chapter, kita akan specifically go for 1D and 2D and also parabolic. Circular belum lagi lah. Okay, so these 2 or 3. Okay. Okay, so let's go for a scenario because I like scenarios. Nak guna nama siapa hari ni? Tadi dah pakai nama Ikri, Rafiq dengan Iqbal. Nak cari nama pun lama kan? Apalah. Okay, let's use Daphne. I like Daphne's name. Okay, so this is Daphne. Okay, so Daphne is moving. Tak tahulah moving macam mana. So let me describe first. So Daphne is walking, and then walking, and then she walks and she walks and she walks until she reaches her destination, which is a shop. This is a shop, a very nice shop. So Daphne is going to the shop lah. Okay, I just made that up. So Daphne is walking to the shop, and from here, let me use a different color. Let's use red. From here to here, which is the destination, this is known as the reference point. Okay, because this is where Daphne started. So the reference point is also the initial point lah. Okay, and we can say that this is xi. Okay, the initial displacement ataupun the initial position. Okay, so bear with me. I'm just please just follow along this story. And then Daphne moves, and then at this point, her displacement is x final. Okay, and this is called her final point lah. Final point ataupun her final displacement. This is the initial point, final point ataupun, let me write this nicely. This is reference point ataupun initial point and then initial displacement. Boleh Initial displacement, final point, and also final displacement. So now my question is, what is the change in displacement of Daphne if I were to write it mathematically? Okay, so mula-mula Daphne ni, dia dekat 0 meter. Kita anggap 0 lah. And then to reach the shop, she has to walk by 10 meter. So just looking at the numbers, you already know Daphne has to walk by 10 meter. Therefore, her displacement is, soalan. Therefore, her displacement is, tak nak cuba ke?
X final minus X initial.
Okay, X final minus X initial. So X final minus X initial. Kalau kita sebut dalam bentuk the numbers that we have here, what would it be?
10 minus 0.
10 minus 0, so it's just 10, right? So Daphne had to walk 10 meters to reach the shop, and this is 10 meter of displacement. Therefore, the change in displacement is delta X equal to final displacement minus initial displacement. So let me repeat myself. This delta means the change, okay? The change in displacement is equal to final displacement minus initial displacement. Okay, so our initial displacement is our reference point. This is where Daphne started. Okay, so this is your first thing that you need to remember. So X is displacement, and the change in displacement is final displacement minus initial displacement. Actually, anything that is delta is final minus initial. So you will see this more for other equations juga. Okay, so this is our first one. Okay, so now I tell you, okay, what is the speed of Daphne? How long did it take Daphne to go to the shop? So Daphne took, dekat sangat 10 meter. Kejap, kita tukar. 10 kilometer, ya Allah jauh sangat, kesian Daphne. Let's be reasonable here. Kesian Daphne jalan jauh-jauh. Let's say it's 1 kilometer lah. Okay, so Daphne tak penat sangat. So 0 meter to 1 kilometer, Daphne had to walk, and that took Daphne 15 minutes. Okay, 15 minutes. Okay lah, acceptable, right? Cuma berpeluh sikit. Okay, so now I'm asking, okay, what's the speed for Daphne to reach the shop? What was her speed? Ataupun what is her average velocity? Kita tulis ni, displacement. Okay, what was her average velocity or what was her average speed. So we can calculate speed by this equation. So speed is delta x over delta t. Okay. So delta x, we know it's x final minus x initial. What about our t? What about our t?
15 minutes.
It's just 15 minutes. Okay. So if I put the 15 minutes, does it represent the delta?
No.
No,
Is it not? Why?
I'm not sure.
Not okay. So anyone wants to guess? Kenapa? So some of you said the 15 minutes is not the delta. It does not represent the change in time.
It has to be in hour.
It has to be in hour. Okay. Boleh. Kalau kita nak in hour, in minutes pun boleh, in seconds pun boleh sebenarnya. But good try. So ada lagi tak guesses on why 15 minutes is the delta or why is it not?
15 minus 0.
15 minus 0. So Daphne started at time 0.
15 minutes tu delta T sebab dia duration.
Okay, betul. So delta T is actually the duration. Okay, so betul. 15 minutes ni duration of Daphne to go to the shop, which is T final minus T initial. Whatever the time is, T final minus T initial, it gave us 15 minutes. Contohnya, Daphne dia bergerak dari rumah, bergerak. She went to the shop at 2:35 p.m. What time is it? Oh, belum lagi. 2:35 p.m. So it took her 15 minutes, right? So 1 plus 5, 250. Good. Okay, 250. 250 p.m. dia sampai. This is our T final. This is our T initial. The duration of T is T final minus T initial, which gives us 15 minutes. So sebenarnya 15 minutes ni our delta T lah. Okay. Because it's the duration of Daphne walking to the shop. Okay, so speed is actually the total distance or the total displacement over the total time ataupun the duration of time. So this gives Daphne's speed. So let's calculate Daphne's speed in terms of SI unit, which is meter per second. So let's try that. Kita buang ni. Oops, that's a 0. Okay, so let's calculate this. So X final dia 1 kilometer 1000 meter minus 0. Okay, over T final minus T initial, which gives us 15 minutes ataupun if we could convert it to seconds, it's 15 times 60. So this is in meter and this is in second. You can do the conversion that I told you, that I taught you earlier. Saya nak cepat je ni. Okay, so 1000, 15 times 60. 1000 divided by 900. So Daphne's speed is 1.11 meter per second. This is her speed. Okay, not bad. 1 meter per second, quite fast. So dia melangkah sebanyak 1 pembaris panjang per second, which is fast. Good. Fast ke? 1000? Fast juga saya rasa. Okay, so that is Daphne's speed. Now what have we talked about so far? We talked about displacement, okay, and we talked about speed. The equation for speed is delta x or over delta t, but in reality, it is actually the total distance over the total time. It's not necessarily displacement. Okay, it's not necessarily displacement. So distance dengan displacement tak sama unless in one dimension. Okay, let me repeat myself. Total distance and displacement is not equal unless in 1D. So kita kat 1D kan? So that's why speed is equal to displacement over the total time. Unless in 1D. Okay, So this is intro scenario. Now kita go for the theory. Let's go. Okay, so I talked about the reference point. The reference point is where you start your journey or where the motion begins. So the motion begins from here going up or here going to the right, and so on lah. Ada vector of displacement ataupun vector velocity. Okay, so the reference point is where you begin. And then we have the position vector denoted as R. Okay, position vector denoted as R. So when Radin is here, Radin moves, and then this is final position of Radin. So we say this is R2, which is final position of Radin, macam tu. So R is position, and R2 minus the reference point, let's say this is R1, oh tak boleh, R1 benda lain. R0 lah, kita letak R0. So R2 minus R0 will give us displacement, the change in displacement. So final position minus initial position gives us displacement. Sama juga macam X final minus X initial gives us displacement. So R dengan X ni interchangeable lah, boleh pakai dua-dua, tak kisah. Sama je. Kadang-kadang they will also use S to denote as displacement. So these are the three symbols lah that they use for position, displacement. They use it interchangeably. But I am more comfortable with X. So banyak textbook and banyak equation akan pakai X lah. Okay. So that is position. And then displacement. So displacement defines a vector that represents, so displacement is a vector. Displacement is a vector that represents the motion of a particle between any two points. So just now we talked about the displacement in one dimension, and we saw that from here to here, it was easy. The total distance was equal to the total displacement. That was in 1D. Okay, and tulisan saya sangat buruk. And then here we have two dimension. Why? Because kita boleh resolve ni jadi X and Y. So this is actually 2D. It's not 1D. So here, let's say this is an ant. And this ant moves this way. This is the reference point because this is where he starts. The ant is the guy. Reference point. Okay. And then dia jalan. Lepas tu, finally, he reaches the sugar cube. Cik, ada matlamat hidup. Okay, so this is the sugar cube that he was aiming for. But dia ikut jalan ni. So, the total displacement is from the final XF to the initial XI. This is the displacement. But the total displacement, the total distance is this one, the dotted line yang tak jadi dot dah. So this is the difference between distance and displacement. Displacement is the shortest distance between the final and the initial. Total distance is actually the path taken. And in 2 dimension, the path taken is usually greater than displacement. Okay, dalam 2D, selalunya path distance dia lagi panjang dari displacement. Displacement pendek. Okay. Okay. So the magnitude of displacement is the shortest distance between 2 points. So in X initial, X final. So delta X, this is displacement. The change in displacement is X final minus X initial. But the total distance is, kita tak tahulah, panjang lagi daripada displacement tu. Let's say it's 10 meter. This is maybe 6 meter. Selalunya distance lagi panjang daripada displacement. Memang selalulah. Okay, displacement is the shortest. So the direction of displacement, is from the initial to the final position. So if I ask you what is the direction of the displacement, it is from the initial to the final, and the arrow is here at the final. So dia punya arah adalah towards final. Ini adalah arah dia bergerak. Okay, this is the direction of displacement. Ini adalah arah dia bergerak. the displacement is independent on the path taken by the motion. So dia tak kisah pasal distance. Tak kisah pun semut tu berlelah, bersusah payah jalan jauh-jauh, ambil, dia cakap dia nak shortcut je. So displacement is actually a shortcut, the shortest distance between the final and the initial. And the direction of displacement is towards the final. Okay, so I hope that's clear on displacement. Okay, so now we talk about distance travel. An object that moves means that there is a change in position. We know this already. It defines the actual distance moved between any two points. Okay, like I said before, distance dia suka ambil tahu semua. Dia nak ambil tahu semua. So this is distance and this is displacement. Displacement only cares about the final and initial position. Doesn't care about the path taken. This is the difference. So distance, displacement. Okay. So now let's talk about Daphne again. Let's go back to our Daphne scenario. Sorry ya Daphne. Nama awak famous hari ni. So Daphne was walking, right? And she walked from 0 to 1 kilometer. Is this displacement or distance? 1 kilometer, is it displacement or distance?
Displacement.
Okay, so some of you are saying distance, some of you are saying displacement. Which one is it? So what is the shortest path? It's here, like it's just a straight line. What was the distance taken by Daphne? Also the same path. So in one-dimensional motion, distance is equal to displacement. What displacement? In 1D. So you say 1 kilometer is her displacement, 1 kilometer is also her distance. Because in 1D, you can't go anywhere. Definitely tak boleh pergi sini, dia tak berdaya. This is one-dimensional cartoon, okay? So definitely is restricted to this line only, which means that the distance is equal to displacement in one dimension. Yang kita tengok tadi, yang semut tu dia suka jalan merata, so the distance is not equal to displacement. Okay, this is 2 dimension because we can resolve it into the x and y. This is 2 dimension. In 2 dimension, displacement is not equal to distance most of the time. Okay, hope that's clear. Anyone confused about that? Kata pula. Okay tak? Did you guys get it?
Yes. Okay.
Any questions so far?
Not yet.
Not yet. All right. So let's move on. Now we talk about displacement of linear motion, and I told you before. Ada chat ni. Ke ada tulis ni? Not yet je. Okay. Ikri tanya, kalau throw ball straight up, dia ada distance which is height, but the displacement tak ada doctor? Yes, that's a good question. Actually, we are going to learn that in free fall. So that's a really good question, Ikri. So kita start kat sini kan. This is our reference point. Okay, this is our ball and our reference point. And Ikri baling bola dia, baling straight up. So straight up and then bola tu jatuh. So the final and the initial is here. This is XF. Let me write that nicely. This is XF and this is also XI. So the displacement is actually 0. Displacement is equal to XF minus XI. But if Fx is equal to Xi, then this is equal to 0. The displacement is 0. However, the distance, contohnya dia naik sebanyak 10 meter and dia jatuh sebanyak 10 meter, naik atas, turun bawah. So the distance here taken by the ball is 10 meter because it is concerned about the path. Okay, dia tak nak tahu pun pasal final dengan initial, yang tu displacement punya kerja. Distance ni nak tahu pasal path. So distance 10 plus 10. 10 goes up, 10 goes down. So 20 meter. 20 meter distance. Displacement is 0. Okay, nanti kita akan go into this. It's called free fall. Yeah, but betul. Displacement is 0. Okay. Okay, so linear motion in one dimension, I told you before, distance equal to displacement, because displacement is always the shortest path between the initial and the final, and this is exactly the same as distance. This is one dimension. Kalau 2D, contohnya dia punya path macam ni, so this is distance and bawah ni displacement. Saya rasa saya dah ulang like 5 times dah by now. I hope you guys get it. Okay, next. Okay, so in 1D, we may represent linear displacement as, we also talked about this one as well, delta x equals to x final minus x initial. Okay. Okay, so here dia punya reference point dengan initial point dia berbeza. Boleh, you can have several initial points, you can have several final points. So for example, macam nak cakap, saya guna nama Fatihah. So Fatihah is here. Okay, mula-mula Fatihah is here and then she walks by 5 meter to her final position. XI, XF. Oh, lepas tu Fatihah cakap, alah nak jalan lagi lah. So she has a new initial position over here. Okay, dia berhenti sekejap waktu ni. Dia berhenti, dia cakap dia penat, dia berhenti. Okay, waktu dia cakap okay nak sambung balik lah sebab why not. So dia bergerak lagi. So this is her new initial position, XI. And dia bergerak sebanyak 10 meter and this is her XF. So actually you can have several initial displacement, several final displacement. You can label this as XI1, XF1, XI2, XF2. Boleh. So what is the displacement between XF1, XI1? 5 meter. What is the displacement between XF2, XI2? 10 meter. What is the total displacement? 15. So you can have in sections is what I'm trying to say here. You can have your displacement in sections, which means that you will have several initial positions and also several final position. Tapi when you talk about total displacement, it should be like the final point, the most final, and the reference point. So this is the final and this is the initial for a total displacement. Okay. But you can break it up into sections. Boleh. Okay, so there will be instances where you have to break it up sebab velocity dia berbeza. Kat sini Fatihah jalan laju sebab dia tak penat. Kat sini dia jalan perlahan. So this is why you need to break it up into sections sebab speed kat sini lain, speed kat sini pun lain. So these are the instances where you have several initial displacement and several final displacement. Okay, nanti kita akan go over an example later on, don't worry. Okay, so now let's talk about average velocity. Average velocity. So here, as you can see over here, we have a sign that looks like, what is it? It looks like kepak rama-rama kot. I don't know, but it looks like that lah. Okay, so it's just this guy. This indicates average of anything actually. So if I say like this, average x. Sometimes they write it like this. This is also average. This is the mathematical notation for average. Okay, so when you have this symbol, it means average velocity. And average velocity is given by the total displacement or the change in displacement, the change in position vector or the change in displacement, the change in displacement over the change in time. Okay, and the change in displacement is a vector, time is a scalar quantity. So the vector divided by scalar, what do you get? What do you get? Vector divided by scalar.
Vector.
Apa? Vector. You get a vector. So vector divided by scalar, you get a vector. Correct. So vector, this guy is a vector. Saya ada soalan yang kelakar tadi dalam chat box. Nanti saya bagi tahu. Vector divided by scalar. Okay, so vector divided by scalar, you get a vector. We already learned this in chapter 1. Okay, so your direction of vector typically follows the vector inside the equation. In this case, velocity follows the direction of displacement vector. Dalam case Daphne tadi, Daphne was walking to the right. Walking to the right, this was her delta x. It's a vector. So her displacement, her velocity. So velocity of Daphne is, saya salah agent nama. Tadi padam pula. Daphne. So the velocity of Daphne is delta x over delta t. This guy is a vector. This guy is also a vector. This is a scalar. So velocity of Daphne follows displacement of Daphne. So if her displacement is to the right, her velocity is also to the right. Okay, this is for velocity and displacement. Okay, buat masa ni. Okay, so I have a question here. Do we have to, kejap saya nak tergelak. Do we have to add the rest time? I can't. Okay, serious. Okay, do we have to add the rest time? Let me just copy paste that. I can't read it. It's not funny, tapi sebab entahlah korang. I don't know what's wrong with me. Kejap. Check. Mana tadi? Copy. Okay. It's not funny Tolong jangan high expectations sangat. Kenapa saya gelak? Maybe I'm just bored. Okay, so do we have to add the rest time when we want to calculate the change of time Fatihah? So kesian Fatihah jadi mangsa keadaan dalam soalan ni. Okay, sorry Fatihah. I was laughing because your name is here and it's cute. Okay, so do we have to add the rest time when we want to calculate the change of time of Fatihah? Betul. You have to add the rest time bila Fatihah stop. Sebab it is part of the total time. Let's see. Tadi tu cakap pasal Daphne, cakap pasal Fatihah kat sini kan? Okay. So tadi Fatihah dia bergerak. Let me write this nicely. It's so awful. Okay, so total displacement dia 15, kita tahu tu. Let's say dia bergerak daripada xi1 to x final 1, 5 meter. Kalau kita ikut rate Daphne tadi, we should achieve this in around 6 seconds. Okay, so Daphne pula. So this is Fatihah. Fatihah is moving 5 meter in 6 seconds. And then she moves 10 meter in, dia kena perlahan kat sini kan, so maybe 12, no, this is at twice je, 20 seconds sebab dia penat kan, mula-mula dia laju, lepas tu dia penat. Waktu dia penat ni dia berhenti sebanyak 5 saat, sekejap je. So the total displacement over the total time ni akan termasuk 6 second, 5 second, 20 second. Total distance ataupun total displacement 5 meter plus 10. Okay, walaupun ada 2 je kat sini, tapi sebabkan dia berhenti, it counts in the total time. Okay, when we talk about velocity, average velocity, we are talking about the total change in displacement over the total change in time. So duration Fatihah nak sampai hujung ni 6 tambah 5 tambah 20. Saya tak kisah dia nak berhenti ke apa ke. Saya tahu masa dia is 31 seconds. This is when she reach here. Okay, displacement pula from here to here 15. Okay, so betul. That is a good question actually. Cuma sebenarnya tak kelakar pun. I don't know why. Okay, so any other questions? Tak ada soalan Okay, everyone is awfully quiet today. Except for the incoming question, which are very good. Okay, so we talked about velocity of Daphne, and I said the average velocity is always the total change in displacement over the total change in time. And kita relate balik dengan Fatihah punya example tadi. Kalau Fatihah berhenti pun kena kira sebab total time duration. Okay. I hope that makes sense for everyone. And then we have a new term. This is called instantaneous velocity. Okay, instantaneous velocity. Let's go back to Fatihah punya example. Kesian Fatihah. Okay, saya tak gelak. Saya cuba tak gelak dah. Mana example tadi? Okay, this one. Let me copy. Oops. Sorry. What time is it? Do we need a break? Okay, after I talk about instantaneous, kita akan take a break. Okay lah, Dr. Gelak tak ngantuk. Saya memang tak ngantuk, korang lah. Sepetang kan? Nak lecture mengantuk-ngantuk susah ni. Okay, total displacement. Saya lukis balik je lah, bukan cantik sangat pun lukisan saya tu. Okay, so Fatihah, kita go back to Fatihah punya example. Okay, so I break it into 3 sections. T0, T1, T2, T3. Okay, bear with me kejap. Okay, so I want to tell you what is instantaneous velocity here. Okay. And then Fatihah starts here. From T0 to T1 was 5 meter. And this is 10 meter. And this is sini ke sini 10 meter. And then this is 7 meter from here to here. Okay. And then we have the time. T1, this is 2 seconds. This is 5 seconds. And ni dah penat 15 seconds. Okay, so dia penat sekejap. Okay, so let's talk about this situation, this scenario. Kita akan cakap pasal displacement. Kita akan cakap pasal average velocity. And then I'll come in and tell you about instantaneous velocity. Okay, so this is Fatihah lah. Okay, Fatihah. Oh, I have a chat here. Sorry Fatihah tu lah. Lepas ni kita guna nama orang lain kesian Fatihah. Fatihah berkorban hari ni. Okay. So Fatihah is moving. Okay. Dia sangat cergas orangnya. So dia bergerak daripada T0 to T1. T0 to T1 is 2 second in duration. It's 2 second in duration. And dia bergerak dari this point to this point. I will call this X1. This is X0, the reference point. This is X1 minus X0 is 5 meter. And then Fatihah cakap penatnya sebab dia jalan laju kat sini. So dia berhenti selama 4 saat kat sini. Okay. And then dia bergerak lagi sebab dia dah recharge. Lepas tu dia bergerak sebanyak 10 meter. And dia bergerak sebanyak 10 meter dalam masa 5 saat. Lepas tu dia penat. Dia berhenti lagi. Dia berhenti lagi dekat sini sekejap. 2 saat je sebab dia dah yakin dengan diri dia. Lepas tu dia bergerak lagi 7 meter tapi kali ni dia penat. So it took her 15 seconds to reach the final point. So this is X2. This is X3. X3 is the XF. Okay, this is XI lah. Kita letak XXI. Oh, tapi confusing dengan satu. Let's just use X0. Now, my question to you is, what is Fatihah's displacement? What is her displacement here? Anyone?
22 meter.
22 meter. Okay, let's see. Okay. This you can go over here. Okay. Okay. So one of you is saying, saya tak tahu siapa yang cakap tadi tu. Thank you. 22 meter. So this is based on 5 meter. So total displacement is delta x, total change in displacement. So you have delta x number 1, delta x number 2, delta x number 3. What does delta mean? It means the change in displacement. And we have like several sections here. Okay, so I can say delta x1, delta x is equal to delta x1 plus delta x2 plus delta x3, which is 5 meter, 10 meter, 7 meter. This is 22 meter. This is the displacement. The displacement is equal to distance because this is one dimension. Okay, sebab yang paling dekat is also the distance, right? Okay, so that is your delta x. What about your total time? What about your total time?
28 second.
28 second. 2 plus 4. Kita tengok. So it's 2 plus 4 plus 5 plus 2 plus 15 second. So that is 6, 11, 13, 80, 28. Okay, 28 seconds. So this is the total time. So here easily dah tahu what is the average velocity here. The average velocity is delta x over delta t, which is 22 over 28. 22 over 28 gives me 0.79 meter per second. Ini adalah kelajuan Fatihah untuk capai dari x0 to x3. Ini adalah average velocity Fatihah, average. Okay, let me. Tapi kita tahu yang Fatihah sebenarnya ada je dia stop, ada je dia laju, ada je dia stop, ada je dia perlahan kan. Sekejap I want to get rid of this. So 0.79 meter per second. Okay. So when we see this scenario, we know that kelajuan Fatihah sebenarnya tak seragam pun. Kelajuan dia tak seragam. 5 divided by 2 is 0.25 meter per second. 10 divided by 5 is 5 meter per second. And then 7 divided by 15 pun nombor yang lain. 7 divided by 15 will get you 0.47 meter per second. So velocity dekat sini, velocity dekat sini, velocity kat sini lain-lain. But kiranya average velocity ni dia bukan merujuk kepada the small sections. Setiap section ni berbeza kelajuan Fatihah. Yang kita tahu average je. Kita tak tahu Fatihah sebenarnya dia laju ke, dia perlahan ke. Yang kita tahu Fatihah jalan sebab dalam kelajuan 0.79 macam mendata je macam robot. Tapi sebenarnya tak, Fatihah penat, kadang-kadang Fatihah cergas. So kita tak tahu pasal kecergasan dengan bila dia penat tu. So average velocity does not tell us when our object ataupun Fatihah bergerak dengan laju ataupun bergerak dengan perlahan. Kita nak tahu average je. So this is where instantaneous velocity helps us. Instantaneous velocity ni dia akan bagi tahu kita, okay, dalam duration T0 to T1, the speed of Fatihah is 5 divided by 2 because that is the x, delta x1 divided by T1 minus T0. Let me write that down. So at this V1, let me use a different color sebab dah macam serabut kat sini. Let's use pink. Okay, V1 is equal to delta x1 over T1 minus T0. Ini adalah velocity Fatihah in this section only. And because this section, the duration of time is smaller compared to the total duration of time, we can say this is the instantaneous velocity of Fatihah from T0 to T1. This is the instantaneous velocity of Fatihah from T0 to T1. Okay, so let's calculate for that. So 5 meter divided by 2 second. This is 5 divided by 2 is 0.25 meter per second. So dia agak lambat. Lambat kan? Okay. 5 divided by 2. Betul lah. 2.5. 0.25 meter. 2.5. Sorry. Patutlah macam lain. Okay, so 5 divided by 2 is 2.5. Sorry. So dia agak laju. Dalam masa 1 saat, dia boleh bergerak sebanyak 2.5 meter. 2 pembaris panjang tambah separuh pembaris panjang. Jauh tu. Dia macam lompat tinggi. Okay, so V1, Fatihah sangat laju. So this is the instantaneous velocity. This is totally different than our average velocity. So what does instantaneous velocity tell us? It tells us what happens in an instant. Nama dia instant. What happens in an instant or what happens in a short duration of time. That duration of time mesti lagi kurang daripada total duration of time lah. So it tells us the velocity that happens in a section of time ataupun in a time frame lah, a shorter duration of time. Okay, and the instantaneous velocity from here to here is also different. 10 divided by 5 is 5 meter per second, lagi laju. That is 2. 10 divided by 5 is 2 meter per second. And then 7 divided by 15 dapat, tak tahu, 0.48 something. So now kita tengok this time over here dah tak terkira. It's not calculated into the velocity anymore, instantaneous velocity. Because this, when we talk about instantaneous velocity, we only want to know the displacement over the time where the displacement happens. 5 meter ni berlaku dalam masa 2 saat. I'm only concerned about that in my instantaneous velocity. But if I'm talking about average velocity, saya nak tahu total displacement over the total time. That includes breaks. Okay, so I hope everyone is okay with that. Ada soalan tak? Okay, lepas ni kita pakai nama orang lain Sian Fatihah. Thank you Fatihah for lending your name walaupun saya tak minta permission. Okay, so tak ada soalan Okay, so I'm going to move on. 1, 2, 3, no? Okay. So next one, speed. So we talked about velocity just now, which was kita ada average and also instantaneous. So average velocity is total displacement, total change in displacement over the total change in time. And then instantaneous, kita measure the change in displacement over the change in time over a shorter duration of time, which happens in an instant. Boleh jadi dalam masa 5 saat, boleh jadi dalam 1 saat, boleh jadi dalam 0.01 second, boleh. Asalkan pendek daripada total duration. Okay, so now speed. Speed is related to velocity. Tapi speed, kita dah cakap pasal speed tadi, it is total distance. If velocity is a vector, speed is a scalar quantity. Sebab kita cakap pasal distance. Distance is a scalar quantity over total time. Oh, ada kat sini. Tengok sini lah, sini cantik. Total distance over total time. So distance is in meter, total time is in second. So your unit is the same as velocity, which is meter per second. Sama je, cuma speed does not have direction and the equation is distance over time. Dia bukan displacement. Okay, so that's the difference. Okay, so we talked about instantaneous tadi. Biasanya instantaneous velocity dia tak adalah this notation, average notation tu tak ada. Equals to limit of delta t approaches 0. This means that shorter duration of time. Maksudnya the change in time tu sangat kecil ataupun shorter duration of time lah. It is so small that it approaches 0. Contohnya 0.001 second, that is delta t approaching 0. Contohlah macam tu. And then delta x is change in displacement over the change in time because it goes for the shorter duration of time ataupun very short duration of time. Kita boleh tulis delta ni in dx dt. Kita boleh tulis this equation as dx dt. You may know this as differentiation and it is differentiation. Kita akan guna ni untuk graph nanti. Okay. So this is for your graphs, dx dt. The delta x over delta t, you use it for Fatihah situation, Daphne's situation, pakai delta lah. Which means final minus initial. Final minus initial. Okay, yang ni differentiation of graph nanti kita akan pakai. And then we talk about, okay, let's take a break. 7 minutes. I know we learned a lot. So kita rest kejap, 7 minutes. So come back at 3:09. Okay, I'll see you then. Jangan tak datang balik pula, okay? Any questions boleh tanya? Okay, welcome back. I hope you guys are back. So ada soalan dari your friend. How to calculate the instantaneous velocity versus average velocity? How to calculate instantaneous lah basically. Let's go back to Fatihah's example. Okay. Kita buang dulu semua calculation ni. Ni. Adakah kita perlu buang Fatihah di sini? Harapnya tak payah. Okay. Okay, 2 seconds. Kesan Fatihah, dia cakap dia nak bersara dah. Lepas tu ada orang tanya lagi. It's okay. It's a good question. Okay. Tapi itu bermaksud Fatihah tak boleh bersara. Sekejap lagi Fatihah bersara. Okay. So let's go back to instantaneous velocity lah. How do you calculate for instantaneous velocity? When we have the time for breaks, right? We have the time for breaks over here. Does it not impact the instantaneous velocity? Okay. So Fatihah was initially at x0. This was at t0, x0, t0. Okay. Displacement 0, time pun 0. So after displacement number 1, she traveled 5 meter and this happened for 2 seconds. The 5 meter displacement happened in 2 seconds. This is not the average. This is 5 meter over 2 seconds. So and then she traveled, she took a break for 4 seconds and then she traveled another 10 meter in 5 seconds. Okay, kalau tengok kat sini, total duration of time is 2 plus 4 plus 5. 6 plus 5 is 11 seconds. But only 2 seconds was used for the 5 meter and only 5 seconds was used for the 10 meter. So ada break kat sini. Apa yang terjadi kat break ni? Zero displacement. Okay, so x1 equals to 5, x2 equals to 10. This break, delta x equals to 0 because she was not moving. So her delta x is 0. And then she also took a break, another break. Delta x over here equals to 0. And then this is 2 seconds. And then delta x3 was 7 meter. And this happened for 15 seconds. Okay, so when we talk about instantaneous, we are talking about a duration of time when the speed at a certain time yang lagi, cuba cakap. Instantaneous velocity is the velocity at a certain duration of time where the time is shorter than the total duration. Okay, so let's take a look at our delta x over here. So is this delta t shorter than our total duration? Yes. Is this delta t shorter than our total duration? Yes. Is this delta t shorter than our total duration? Yes. And this one too, and this one too. So can I say delta x1 over delta t1, which is t1 minus t0, equal to the instantaneous velocity v1? Yes, sebab duration of time kat sini is smaller than the total duration of time. The time here, the duration of time here is smaller than the total duration of time. Boleh ke saya nak cari instantaneous velocity kat sini? Boleh, let's try it. So let's delta x equal to 0 over 4 seconds. 0. The instantaneous velocity at this point where Fatihah was resting is 0. Kenapa nama dia instantaneous? Sebab duration of time tu adalah kecil. It's the short amount of duration of time when the displacement happens. Okay. Berbanding dengan average velocity, kita kena ambil tahu semua delta t ni, kena tambah semua delta t, kena tambah semua delta x. Baru dapat average velocity. Instantaneous hanya berlaku pada duration yang pendek sahaja. Okay, so next one. This one. So delta x2 over 5 second. Delta x2 is 10 meter. So this is the instantaneous velocity over here. The delta x2 over 5 second. Kat sini pula waktu Fatihah tengah break. Boleh. Delta x equals to 0 over the time that she took. 2 second. Delta t equals to 2 second. This equation is instantaneous velocity, but it is 0. So the instantaneous velocity of Fatihah when she was resting is equal to 0 because no displacement happened. And then kat sini sama juga instantaneous. So all these instantaneous velocity make up. Bila kita campur semua ni, kita akan dapat average velocity. Okay? Tapi janganlah campur betul-betul macam tu. Korang kena ikut formula lah. Delta T total dengan delta X total. Okay? So is that clear? Okay tak? Doctor, does that mean the instantaneous velocity does not have the change? It does have the change. Instantaneous velocity has the change but in smaller. The change is smaller. Okay, kita tengok balik equation ni. Oh, faham. Thank you, Doctor. Okay. So, saya cakap pasal the change. So, some of you is asking, one of you is asking, so kalau instantaneous, adakah change tu tak ada? Okay, kalau kita tengok equation ni, there is delta R over delta T. Cuma our delta T ni is so small compared to the total duration. Kan kita dah cakap tadi, yang ni total T. Yang ni besar. Yang ni kecil. Sebab 2 second je. So ni 2 second, kecil. So limit approaches 0 ataupun limit approaches a very small number. So instantaneous adalah velocity. So instantaneous velocity adalah velocity yang berlaku pada tempoh masa yang sangat pendek. A short duration of time. Okay, selalunya bukan 2 second. Selalunya dia kasih 1 second ataupun 0.5 second ataupun 0.001 second. Boleh, that can be instantaneous velocity as well. Because it happens in an instant. Sekelip mata. Okay? So I hope that helps. Moving on. Kalau ada soalan lagi boleh tanya. Okay, acceleration. So kita dah tahu what average means. Average always means the total change over the total change lah basically. So here average acceleration is defined as, kita patut ada simbol kat sini, delta V ataupun the total change in velocity over the total change in time. Okay, and we know that velocity is delta X tadi kan, kita dah belajar tadi pasal velocity. And we know that this guy is delta X over delta T. This guy punya unit is meter per second. Now, this guy is divided by another second over here. So this gives us units meter per second squared. Okay, so this is our unit. This is the SI unit. It is a vector quantity. This guy is a vector because velocity is a vector. However, tadi I told you velocity will always follow the direction of displacement. Dia akan follow me. Okay, tapi acceleration not necessarily. Do not follow me. Okay, velocity dia follow displacement punya direction. Acceleration tak semestinya follow velocity punya direction. Kita akan tengok nanti kenapa dia tak follow and kenapa dia follow. Okay, so acceleration, average acceleration is the total change in this velocity over the total change in time. When the sign of velocity and acceleration are the same, meaning to say acceleration is positive, velocity, change in velocity also positive. This means that the speed is increasing. When the sign of velocity and acceleration are opposite direction, for example, acceleration negative, velocity positive ataupun acceleration positive, velocity negative, ini bermaksud the speed is decreasing. Okay, nanti kita akan tengok situasi, another scenario with another name from you guys, yang when acceleration follows the sign of velocity and when it does not follow the sign of velocity. Okay, when we talk about average, we will talk about instantaneous acceleration too. Okay, and sama juga, instantaneous acceleration is the acceleration that happens over a short duration of time. Kat sini dia tulis delta t approaching 0, which means that the duration of time is super small. So kalau kat sini 10 second, I want to see what is the acceleration over here. Hey, this delta t is super small. It approaches 0. That is your instantaneous acceleration or instantaneous velocity. Okay, it's whatever that happens during that short duration of time is the instantaneous acceleration or velocity. Okay, so sama juga equation, instantaneous acceleration is the change in velocity over the change in time, tapi change in time is short. Okay, kita tengok example. Let's see example. Okay, let's talk about the example now. Share screen. Okay. Okay, I want to share this ebook. I want to share. Is it this one? Okay, it's this one. Okay, I'm going to put it over here. Okay, let's look at this example. Okay, this is a train, right? It's a train. I think I should screenshot it first so that I can conteng later. Take screenshot, save to desktop, stop sharing. Share screen again, over here, new slide. Okay, insert. Okay, so I'm inserting this picture of a train. So let's take a look at this train. Kita nak cakap pasal acceleration. So this train, bila kita, I'm sure you guys have dah pernah naik train sebelum ni, and you know that when a train is stopping at its station, okay, when a train is stopping at its station, it will slow down, right? It will slow down. And then let's say it started from 50 meter per second at this point, and then kat sini dia 40 meter per second, and then kat sini 30 meter per second. Kenapa saya pakai warna oren? Tak tahu lah. Tak nampak. Sekejap. Let's use pink. Will it show? 50. Tak nampak juga. Apalah. Okay, 50 and then 40 and then 30. Tak berhenti lagi ni. 20 and then 10 sampai it goes to 0 meter per second. So what does the train do? It is slowing down. It is slowing down from a high speed sampai it comes to a complete stop, which is 0. So this is velocity, velocity 50, velocity 40, velocity 30, velocity 20, velocity 10, velocity 0. So these are the changes in velocity. When we have a change in velocity over a duration of time, we will have acceleration. The only thing that we don't know is what is the acceleration? Is it a positive or is it a negative? Okay, so let's see. We started with 50 meter per second and we ended with 0 meter per second. Can anyone tell me what is the acceleration? Is it a positive or a negative? Try it.
Negative.
Negative. Why is that?
Because the train is slowing down.
Because it's slowing down.
Okay, it's slowing down. But in terms of the equation, how did you know it's negative?
0 minus 50.
0 minus
0 minus
50.
50. Okay,
Bukan
over the time,
negative
we
50.
do 30 seconds. So 30 seconds here, meter per second. So this is your change in velocity over the change in time. So you get minus 50 over 30, betul? So this gets you minus something acceleration. Minus 50 divided.
Negative 1.67.
Okay, negative 1.67, thank you. So the units is meter per second squared. So when you get acceleration to be negative, even though your velocity is positive, okay, velocity of positive, walaupun dia menuju ke kosong, the velocity is positive. It's positive 50, positive 40, positive 30, positive 20, positive 10. But you ended up with a negative acceleration, which means that the velocity is slowing down. Itu je lah maksud dia sebenarnya. Okay, can anyone tell me why I said that the velocity is positive? How would a negative velocity look like? If this
The
is
train
positive,
would move backward.
it would move backward, betul. This is the direction of my V vector. It's moving towards me. If the train was moving the other way, this would be a negative V. Ni tak ada kaitan dengan acceleration tadi, tak ada kaitan. It's just moving the other way, so it's a negative V. Negative 50, negative 40, negative 30, negative 20, whatever. Tak asalkan direction dia terbalik, because it's a vector, asalkan direction dia terbalik, it's a negative value. Okay, it's a negative vector. Okay, so that is negative 1.67. So acceleration becomes positive if the train keeps on accelerating. Sorry, if the train keeps on speeding. And this happens kalau ni bukan station dia lah. Dia cakap, okay, saya tak nak siapa-siapa naik, I'm going to speed up. So daripada sini dia 30 kan, lepas tu dia tengok ada orang naik, tak boleh. So dia lagi laju. 50, 60, and then dia maintain 60 meter per second sebab dia tahu tak siapa boleh naik dia dah. Okay, dia maintain kat sini 60 meter per second. Daripada sini 30, 40, 50. So there is a change in velocity over here, and the change in velocity over here is positive over the duration of time. What about over here? What is my acceleration over here from 60 to 60 to 60 ni? 0.
Constant.
My change in velocity is 0. Why? Because my V final minus V initial is sama. So 60 minus 60 is 0. Okay, kenapa saya tulis ingat pun saya tak tahu. Okay, so my acceleration over here at this section of time, delta V over delta T, whatever the delta T is, whatever that duration is, it is equal to 0 because my velocity is no longer changing. My velocity is the same. When there is no change in velocity, my acceleration is 0. Okay, when there is a change, my acceleration can be positive or negative. It is a positive if the train speeds up. It is a negative if the train slows down. So in this case, it is speeding up from 60 to 30. This is the final over here. This is our V final. This is our V initial. And whatever that duration is, so I get a positive A, right? And then you're asking me, Doktor, kenapa kita ada dua initial, kenapa kita ada dua final? Can anyone tell me why? Anyone wants to try? Kenapa kita ada dua initial, dua final? It's related to the shorter duration of time. Shorter duration of time.
Instantaneous.
Yes, it's an instantaneous acceleration. When we talk about average acceleration, we want to know the entire velocity over the total duration, total change in velocity over the total change in time. But for instantaneous, we are concerned about a section sahaja. Okay, I want to know what is the instantaneous velocity over here. I can find it. I want to know what is the instantaneous velocity over here. Boleh. Nak cari instantaneous velocity kat sini? Boleh, whatever value that is. So instantaneous, you can break a duration, a total duration, you break it into several parts. That is your instantaneous acceleration or instantaneous velocity. Jadi dalam case ni kita cakap pasal instantaneous acceleration lah. Okay. So, any questions about this one? So everyone's okay? Okay. So if I were to find out what is my average acceleration, let's draw this nicely. Okay, I want to know what is my average acceleration. Okay. What color is going to show up here? I think orange would look okay. So I start with 30 and then I go, no, orange tak nampak. Tak apalah, 40 meter per second, 50, right? 50 per second, and then 60 meter per second over here, 60 meter per second over here, and then I just go sama lah value macam tadi, and then from here to here it took me 2 seconds, from here to here 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 took me 2 seconds. Okay, because train ni bukan Fatihah, dia tak ada break, dia tak ada berehat. Dia cergas, dia sentiasa. Okay, so what is my average acceleration? How can I find my average acceleration? Average, okay. So equation dia delta V over delta T. What is the value that I should put here? No one? Okay, kita cakap pasal instantaneous tadi kan. When we talk about instantaneous, we are saying about V final minus V initial, but over a shorter duration of time. Kalau average, kita nak tahu what happens in the change in velocity over that entire duration. So what is the entire duration in this case? What is the entire duration here?
10 seconds.
10 seconds.
10 seconds. 1, 2, 3, 4, 5. Okay, 10 seconds. So delta T equals to 10 seconds. And how do I find my delta V here?
300.
300. Kenapa?
At the 30 until 60.
30 until 60. So tambah semua dapat 300.
Yes.
Okay. Thank you for trying that, for giving me that answer. Anyone else wants to try? What is delta again? What is delta?
Change.
What does delta mean?
Change.
Okay, what is the equation for delta? Always.
Final minus
Final minus initial. What is the final minus initial here? For
Oh,
velocity.
60 minus 60.
30.
Minus 50.
Yeah,
Oh.
that is your average acceleration. We don't care what happens in between. Kita tak kisah Fatihah dia gerak laju ke, gerak perlahan ke. Yang kita tahu final dia apa, initial dia apa, total duration dia apa. So that is our average. Tadi kita cakap pasal Fatihah untuk velocity. Sama juga macam acceleration. We just want to know what is your final velocity, what is the initial velocity, what is the change in time, total time. Okay, so the answer here is 30 over 10 is 3 meter per second squared. Oh, that's quite slow. Okay, but never mind. Okay, so when we talk about average, final minus initial over the total duration of time. But when we talk about instantaneous, I want to know what is the instantaneous velocity from here to here. So what should I do? Instantaneous acceleration. What should I do here? What is the equation?
40 minus 30
40 minus 30 over 2 seconds. So this is your instantaneous acceleration at this point, at this duration of time. The 2 second ni, the value is here. This is the value, 10 divided by 2, 5. 5 meter per second squared. Okay, so the instantaneous acceleration tak sama dengan average acceleration sebab cara kira dia pun lain. Okay, and then kat sini 60 to 60 over 2 second. What is the acceleration here? Instantaneous acceleration. Zero. Okay, so here it was 5, here it was 0, but the average acceleration is 3. Dia tak kisah apa jadi kat tengah-tengah tu. What it cares about is final minus initial. This is for average. Okay, untuk semua average actually, velocity pun dia tak kisah apa jadi kat tengah-tengah. Fatihah tengah berehat ke, Fatihah tengah perlahan ke, Fatihah tengah laju ke, dia tak kisah. Yang dia tahu apa jadi kat hujung, dengan hujung lagi satu. Okay, so that is your average. Okay, any questions? No chat for me. Okay, so sama juga, the equation is delta V over delta T. Limit of T, delta T approaches, the limit of delta T approaches 0, which means that duration of time is small. And then we have the change in position, delta X ataupun X. And then the change of position over the time interval, delta X over delta T gives us velocity. Then the change of velocity over the time interval gives us acceleration. This can also be written as this way, but typically we focus this for graphs. Okay, but the D ni, mathematical notation D indicates small change. Okay, so change lah kan, delta pun change juga. That's why it's equal. Okay, so let's try this example. I'm gonna assign people because saya penat cakap. Let me rest for a while. Okay, so Fatihah dah jadi korban tadi. So kita akan spare dia. Daphne pun dah. Can we get Firna to do A? Firna belum jadi korban siapa-siapa lagi kan? So Firna akan berkorban untuk kita. Firna. And then B. Firna is doing the average speed. Is Izzati there? Izzati ada tak?
Yes.
Ada kan? So Izzati, can you do it? Should I call you Alia or Izzati? I forgot lah. Izzati ke Alia? Alia, okay, sorry. Alia. Firna and Alia. Okay, so Alia is doing velocity, which is a vector. Firna is doing speed, which is a scalar quantity. So let's do this. Hopefully in 7 minutes we can finish. Everyone else, please try. If Firna and Alia doesn't get it, you guys have to help me. Okay, so please try it. 7 minutes from now. 3.38, 3.4. Kalau ada soalan boleh tanya ya. Okay. Oh, Izzati cakap, Alia cakap tak dapat. Tak apa, kita tengok apa yang awak dapat. Kita tengok what did you do. It's okay. Alright, so let's see. Firna, are you done? Is Firna done?
Yeah, but I got the wrong answer, Doctor.
Firna pun tak dapat. Okay, tak apa, kita tengok apa Firna dapat. Let's see what you got. Macam mana Firna kira?
Actually, I just take the average speed at 80 km per hour plus with average speed of the 130 over the 2.0 hours.
Okay.
So yeah, I got 145 km per hour. That is the average speed that I get.
145
Km per hour.
Oh, kilometer per hour. Okay. Okay, so remember your average kan, when we talk about average speed, kita cakap pasal the change in distance over the total change in time. So kat sini maksudnya Firna tak ambil, you didn't take into account that the motorist stopped for 15 minutes lah.
Yes.
Okay. Okay. So this is how Firna did it. She added the two speeds together and dapat 145. Tapi ini bukan average kan. Kalau average sebetul-betulnya bahagi 2 lah. Okay. So that was Firna's approach. So how should we actually do it? Okay, let's do it. So motorist drives north for 30 minutes. Mula-mula dia bergerak ke arah north. This was for 30 minutes and at average speed of 80 km per hour. Kita tulis dulu. And then stops for 50 minutes. Dekat sini dia stop. Kita buang dulu north ni. Kat sini dia stop sebanyak 15 minutes. And then continues east. Continues east for, continues east. This is east to the right. North ke atas, east to the right. 130 kilometer. The duration of time dia 2 hours. Okay, what is his average speed? Now, the equation for speed is actually total distance over total time. Okay, so what Firna did was dia ambil speed. Dia ambil speed je, dia tak ambil distance, dia tak ambil time. Okay, so what should we do here is we calculate the distance first. So the distance here is 80 km per hour. The distance yang dia travel is 30 minutes in hour is 0.5 hour. Kan 30 minutes jadi hour, sorry tu bunyi hujan. 0.5 hour. So this gives you 40 km. This is your first distance. Okay, and then your second distance is 0. Kat sini 0, tak ada apa-apa sebab dia stop. And then your second distance, your third distance is 130 km. So ni adalah distance dia, 40, nombor 1, nombor 2, 130 km. Dari segi time pula, ni adalah distance. Dari segi time, kita kena ambil tahu dia bergerak sebanyak 0.5 hour yang pertama ni. And then dia stop 15 minutes, so 0.25 hour. And then bergerak sebanyak 2 jam. So total time kat sini adalah 2.75 hour. So total distance over total time gives me 170 km. Kalau saya kira betul lah, 170 km over 2.75 hour. Okay, so that will give me 61.82 km per hour. Okay, so ni adalah distance. This is distance going up, going to the right. What is the displacement? Anyone? What is the displacement here?
136.01.
136.01. Macam mana kira
Guna Pythagoras.
Guna Pythagoras. Okey, betul. Memang kena pakai Pythagoras sebab equation displacement cakap it is the shortest distance ataupun the shortest length. Mana saya nak campak ni? Okay, kat sini lah dulu. So kalau kat sini adalah 40 km, dia berjalan sebanyak 40 km. Kat sini dia berjalan sebanyak 130. Kita boleh kira shortest from initial to final adalah guna Pythagoras theorem. So mana saya nak tulis? Kita pakai biru lah. Okay, so ni 130. Yang ni kita dapat tadi 40 km. Yang ni 30. Sebagai Pythagoras theorem tadi, thank you siapa yang tolong saya tadi tu, 130 squared, 40 squared and then square root that, dapat 136. Okay, 40 squared, 130 squared, square root this dapat 136.01 lah kalau nak betul-betul 2 decimal point. Okay, 136.01. Ini adalah displacement. Macam mana saya tahu ni displacement? Because displacement is only concerned about your final point and your initial point. Dia nak tahu the shortest distance from final to initial. Dia tak kisah pasal path. Path tu adalah distance. Yang panjang ni distance. Yang pendek is displacement. Okay, sekarang ni kita dah bagi hint dekat Alia. So Alia, how do you want to find velocity now? Boleh tak revise? Sebab tadi awak cakap tak tahu kan? Okay, sekarang kita dah bagi displacement. So how would you calculate velocity? Okay.
Displacement tu.
Okay, change of displacement which is?
136.01.
Over the change in time. So 136.01 over?
2 minus 0.5.
Berapa?
2 minus 0.5.
2 minus 0.5. 2 tolak 0.75. Sebab apa tolak?
Sebab change of time.
Sebab change of time. Okay, so change of time awak ni 2 tolak 0.75. Okay, sekarang ni change of time is the duration untuk sampai dari initial to final. Untuk dia sampai dari initial to final, berapa masa yang diperlukan? So dia start kat sini waktu kosong. 30 minit, 15 minit, 2 jam. So dia sampai final. Berapa duration time kat sini? Berapa duration time yang diperlukan untuk sampai dari initial ke final?
2.75 hour.
2.75 hour. Tak ada tolak kan? Dia total duration of time termasuk breaks. Kita cakap pasal average sekarang ni. Total time adalah termasuk breaks. This is not instantaneous. We are talking about average. Speed tadi kita cakap pasal total distance and total time. And dia agak straightforward sebab kita just tengok total distance and then tengok total time. Tapi displacement untuk average velocity, we are looking at displacement. Displacement yang part tricky dia, tapi total time is still the same. It's 2.75. Dia nak sampai dari sini ke sini, dia kena lalu jauh. Tapi masa yang diperlukan adalah 2.75. Walaupun displacement dia pendek. Sebab displacement ni ialah shortest length, shortest distance. Ataupun shortest length lah. Walaupun shortest length, masa yang diperlukan masih 2.75. So, it's still that So, the answer is 236.01 bahagi 2.75. So, kita akan dapat 49.46. Okay, Alia, saya tanya lagi 46. Kalau salah tak apa, we are learning here, no pressure. So, how did this person get 17.1 north of east? Macam mana nak kira angle dia? What is your idea on how to find it? Macam mana nak cari angle dia? Cuba je, kalau salah tak apa. Okay, anyone wants to help Alia? Tak. Doctor, is the degree
Angle
important for the answer? Yes, the answer is degree tu penting sebab dia vector. Okay, tadi siapa nak try tadi? Sorry, saya terpotong cakap.
oh okay. Doktor tu yang kat triangle tadi tu, yang kat belah kiri tu,
Kiri, okay,
dia
kiri.
kat bahagian yang bawah tu.
Ni,
Kira tu pakai tan,
pakai tan. Okay.
tangent.
So your equation is tangent theta, assuming this is your theta. Okay, pakai apa? What is your equation?
130 divide by 40.
Divided by 40. Okay, thank you. So dapat theta as, so inverse tangent of 130 divided by 40, betul? So dapat 72.89 ataupun 90. So macam mana kita dapat 17.1 ni? Jawapan ni hampir tepat. We are
Minus
90 degree minus answer.
minus
90
by
degrees
90
minus answer. Why kena minus 90 degrees?
to find the other half of the degree, the real one, starting
real
from
one.
0.
Starting from 0. So nak cari kat sini lah. 17.1. Okay, jawapan tu betul. Tapi yang sebenarnya kenapa kita nak 17.1 ni is because it refers to the positive x-axis. When we talk about vectors, we always refer back to the positive x-axis. Kalau angle dia atas x-axis, positif. Kalau angle dia bawah, negatif. Okay, always go back to the positive x-axis. Kita tak nak tahu angle yang merata-rata, kita nak tahu with respect to x-axis. Always. So dapat kat sini 72.9, 90 tolak this guy, dapat 17.1 lah. Okay, thank you for that answer, betul. Alright. So that is how you get the 17.1, and then dia nak cakap north of east, we refer this as east, and then towards the north, pergi sebanyak 17.1. Of east is our reference point ataupun east is our x-axis. So of east, kita go to north by 17.1. Kita go towards north. Okay? Any questions about this one? Faham tak semua? So speed is total distance over total time. Kena kira lah distance satu-satu. Kena kira semua time. And then average velocity is the total change in displacement, which is final minus initial over the total duration of time ataupun the total change in time. Okay, change in time is duration of time. Change in time is duration of time. Okay, pakai tan minus 1, 40, 130, boleh ke doktor? Boleh, sama je. So your friend is asking tangent theta equals to 130, boleh ke pakai macam ni? Boleh, sebab ini bermaksud saya pindahkan tangent to the other side. It's the same thing. Okay. Doktor, kalau ambil angle yang doktor tulis 2 hours tu sama je kan? Doktor tulis 2 hours. Yang ni. Najla, saya tak faham soalan awak. Boleh bagi tahu balik?
Yang dekat, doktor tulis F dekat segitiga tu kan?
Kita tulis dekat segitiga.
yang F tu, boleh ke kalau ambil angle kat situ?
Sini. Boleh. Tapi selalunya kita akan ambil vektor daripada initial lah selalunya. Tapi jawapan dia akan sama kan? Cuma conventionally yang bagi kita senang faham adalah ambil vektor daripada dia punya initial with respect to the x-axis. Tapi kalau pakai kat sini pun dapat jawapan sama kan. Cuma nak cerita with respect to x-axis tu susah sikit lah. Sebab dia bawah negative x-axis. Doctor, if I just put the answer of magnitude average velocity and not include the degree, is it acceptable? No, because velocity is a vector. Vector always has direction. Kena ada direction. Ikri, awak cakap apa ni? No 40/130. Tak faham. Bagi tahu balik kat saya.
Kalau yang macam kita guna x-axis tu, tarik ke atas kan jadi 130 dekat ni. Faham tak?
Sekejap lagi sekali. Kalau kita tarik 130 tu pergi atas.
Maksudnya macam guna
No.
vector component lah.
Guna macam daripada x-axis ni tarik ke atas jadi sini adalah 40. 40. Tunjuk macam mana ni?
Siapa nak tolong Ikri explain kat saya tak? Saya tak faham. Sorry. Saya yang tak faham, bukan Ikri yang tak faham, saya yang tak faham. Ikri, cuba ada orang yang faham Ikri tak? Boleh cerita kat saya. Normally soalan ni berapa markah doktor? Final answer akan kira sebagai 1 markah. Tu final answer. Jalan kira ada markah juga. Jalan kira, so yang ni kita ada total distance ni mungkin 1 markah. Total time yang betul 1 markah. Final answer 1 markah, maybe 3. Boleh jadi. Sebab jalan kira pun kita kasih markah sebab selalunya korang tak naklah doakan tapi most of the time student mess up jalan kira. So final answer memang dah ke laut lah. So kita nak kasih markah, kita tengok jalan kira. Kadang-kadang jalan kira dia betul tapi final answer salah. Kadang-kadang jalan kira salah, jawapan final pun salah. So kita nak cuba cari markah. So jalan kira selalu ada markah lah. Okay, so jangan malas tulis. Jangan malas tulis. Okay, so I think that's it. Oh, dah terlebih masa. So if there is no more questions, you are free to go. Class has ended. Thank you so much everyone and have a great rest of the day. Kalau tak sekali ke memang tak dapat markah untuk answer. Tak dapat.
Thank you, Doctor.
Welcome, bye-bye.
Thank
you,
you,
Doctor.
Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Welcome, bye-bye.
Thank you, Doctor.
Welcome, bye. Have a great day.